Good morning once again, students. This is your maths teacher. As we were continuing with chapter 1, which is real numbers. So we are coming to the end of this chapter now, as this is our last exercise, exercise 1.4, where we are going to determine the nature of decimal expansions, right? So before starting the exercise, again, we will revisit something which you have studied in ninth class. In ninth class, exercise 1.3, first question was write the following in decimal form. You might have remember, right? This was the question in ninth class. If I want to convert it into decimal form, how will you convert? By, in this question, you know that if in denominator you have two zeros, then directly I can write it in the form of decimal expansion. So your decimal expansion is 0.36. Now come to this part. This is 1 upon 11. If I want to convert it into decimal expansion, how will you solve it? We have to divide 1 by 11. Right? So what procedure you followed in ninth class? You have followed long division method, by which what you are going to do? 0, take decimal, take 0, as it is also less than 11. Again, by putting 0, we are coming to this part. 11 nines are 99. Again, you will get 1 by decimal, 0, again 0, and that nines are 99. Again, you are getting 1. Again, you have to put 0, and here nines are 99, and it will continue. So therefore, you will write this decimal expansion as 0.09 bar. Bar shows that these two digits are repeating, right? After decimal, as it is not terminating. It is non-terminating, repeating. Remember? Now come to third part. What you are going to do? 8 4s are 32 plus 1, 33 upon 8. Now we are going to divide 33 by 8. 8 4s are 32. 1, take decimal, put 0. 8 1s are 8. 2 here, again 0. 8 2s are 16. Again you will take 4. By decimal put 0. 8 5s are 40. What kind of decimal expansion is here? 4.125. Now, I am asking you one question, that what kind of decimal expansion are these? You must be aware that this is terminating. This is terminating. This is non-terminating. Non-terminating, reoccurring. Reoccurring expansion. And last again, terminating. Terminating means which terminates after some of the digits of decimal. It is terminating, it is non-terminating, reoccurring, it is also terminating. Now, come to your 10th class. Here, we have done this exercise with the help of division method or by these zeros method, right? But here in 10th class, without division, we have to learn how we can determine what kind of decimal expansion is there, right? For that purpose, I will tell you how you are going to solve it without division. What you are seeing in these three parts, check the denominator. If I will do the prime factors of denominator. Prime factors of denominator. In first part, prime factors of denominators will be, it is 100. So how will you write? 2 into 50. And what will be the prime factors of 50? That is again 2 into 25 and 5 into 5. So 5 5 to 25, 25 to the 50, 50 to the 100. So these are the prime factors of 100. Now prime factors of 11 will be 11 only. 11 into 1, nothing else. So 1 is not prime, therefore 11 only. Come to this part, 8. Its prime factors are 2 into 2 into 2. So by these examples, you will get to know that if denominator is in the form of the prime factors 2 and 5 only, then it will be terminating decimal expansion. Otherwise, it will be non-terminating or it can be non-reoccurring, right? So, by the help of these two expressions, you will get to know what kind of decimal expansion is. So, we can say that if in P by Q form, where Q is not equal to 0, Q is having prime factors of the form of 2 raised to the power m into 5 raised to the power n, then this is a rational number which terminates. Which is terminating rational number if Q is in the form of 2 raised to the power m and 5 raised to the power n, where m and n are non-negative integers. Non-negative integers. Now we are starting our exercise 1.4. This is our first question. Question number 1 is, without actual performing the long division, state that following rational numbers will have terminating or a non-terminating repeating decimal expansion. It means जो आपने 9th क्लास में लॉन्ग डिवीजन मेथड किया था उसके बगैर किए, you have to tell that whether it is terminating or non-terminating repeating decimals. So how will you get to know this thing? So come to first part. First part is 13 upon 3125. Simply what you have to do, you have to find prime factors of denominator 3125. So as you can see that it is not divisible by 2, by which you are going to divide it. 2 plus 5 is 7, 8, 8 and 3 are 11. So it is not divisible by 3 also. So let's take 5. 5 6 are 30, 5 2s are 10, 5 5s are 25, 6 25. Now again 5, 5 1s are 5, 5 2s are 10, 5 5s are 25, 5 2s are 10, 5 5s are 25 and again 5 5. So it is what? We can say that the denominator can be expressed in the form of 5 raised to the power 1, 2, 3, 4, 5. As we have discussed that if denominator is of the form of 2 raised to the power n into 5 raised to the power m, then it terminates. So here you can express that it can be written in the form of 13 upon 2 raised to the power 0 into 5 raised to the power 5, where n is equal to 0, m is equal to 5. non-negative integers. So what kind of expression or decimal expansion it will be? Terminating. It is terminating expansion, right? It is terminating decimal expansion. Now, third part we are taking 455. What you are going to get? 455. Again, 5. 5 nines are 45. 5 is a 5. 91 is the factor of what? 7. 7 ones are 7. 7 threes are 21. So 13 ones are 13. So it will have 64 upon 5, 7 into 13. So its prime factors are other than 2 and 5. Therefore, it is non-terminating repeating expression. Right? It is non-terminating repeating because its denominators factors are other than 5 and 2 also. Like 7 and 13 is here, therefore it is not terminating, it is non-terminating repeating. Last again, other than 2 and 5, it is having 7 also. So it is also non-terminating repeating. Non-terminating repeating rational number. So this way, without long division, you can find out which one is terminating and which one is not. Now next is second question. Now your second question is same as first one. Means it is following first question. Same parts are given, but in this section, after getting or after determining which rational number is terminating or non-terminating, we will write it in the form of decimal expansion as well. So this is our second question. First of all, you must be knowing about this, whether it is terminating or non-terminating. Again, I am telling you 17 upon 2 raised to the power 3. As it is in the form of 2 into 5 factors, therefore it is terminating. It is terminating. And as it is terminating, we have to convert it into decimal expansion. How will you do it? You will write it is in the form of 17 upon 2 raised to the power 3 into 5 raised to the power 0. Actually, if we don't want to go with long division method, we always used to take a 5 or 2 to complete it in the denominator as the power of 10, right? So for that purpose, what we are going to do, we are going to multiply it by 5 in numerator and 5 in denominator. So what we are going to get? 17 into 5 upon 2 raised to power 3 into 5, as 5 raised to power 0 is 1. So 2 raised to power 3 into 5. So 2 5s are 10 and 2 raised to the power 2 will be resting. So 5 7s are 35. 5 1s are 5 and 3 8. It is 85 and now it is written 4 into 10. So 4 2s are 8. 4 1s are 4. And how much it is left? 1. So 5, 4 2s are 8, 4 5s are 20. And 10 is here. So again you have to shift decimal at one place. So 2.125 is its decimal expansion. Now our fifth part. It is 29 upon 343, and I hope you must be aware that 343 is the cube of 7. Or you can use again LCM method or factorization method if you are not getting. So as here there is no prime factorization of 2 and 5, therefore what kind of decimal expansion will be? Non-terminating. It is non-terminating. Therefore there is no need to find its decimal expansion, because here they are saying that if rational number is terminating, then you have to find its decimal expansion. So here there is no need to find decimal expansion. Now come to 10th part. It is 210. Again you must be aware that 21 is the factor of 3 into 7 into, it is 10, 0, so again 2 into 5. Here 2 into 5 is there, but other than these two, we have 3 and 7 as well. So again it is non-terminating. So therefore there is no need to find its decimal expansion. Non-terminating, repeating. So there is no need to find decimal expansion. So wherever you will get the terminating rational number, then you have to find this way the decimal expansion. Now this is our last question of this exercise, even of this chapter as well. Question number 3 says that the following real numbers have decimal expansion as given below. In each case, decide whether they are rational and of the form of P upon Q. What can you say about the prime factors of Q? Prime factors of Q. Let's see. These are the 3 parts which we have to convert into P by Q form, and we have to tell about whether they are terminating, non-terminating, repeating or irrational numbers. So first part is 43.123456789. So how many digits are there? 9. So after removing decimal, how many zeros you are going to get? 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So after removing decimal from here, you are going to get 9 zeros. 5, 6, 7, 8, 9. So the representation will be 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 upon 10 raised to power 9. Now factorize your 10. 10 can be factorized in the form of 2 and 5. 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 upon 2 into 5 raised to the power 9. So as this can be written in the form of 2 raised to the power 9 into 5 raised to the power 9. Therefore, here I am not repeating the numerator. In denominator, I am repeating 2 raised to the power 9 into 5 raised to the power 9. Therefore, it is terminating. It is terminating, and this is P by Q form. After this expression, how will you write? 43, 1, 2, 3, 4, 5, 6, 7, 8, 9 upon 2 raised to the power 9 into 5 raised to the power 9. So it is terminating, or terminating means it is rational number. Now come to second part. As you can see from these digits, neither they are terminating nor repeating. Therefore, it is non-terminating. If it is non-terminating, non-repeating, then we can say that this is not a rational number, so it is irrational, and which cannot be written in the form of P by Q. Now last part, again I will ask you that you must have studied in 9th class how to convert such kind of digits in P by Q form. What was that? Let x is equal to 43.123456789. As these digits are repeating, so again we are going to write 1 2 3 4 5 6 7 8 9 and so on, right? So you must be remember that as many digits after decimal, you have to take that much zeros with 1 multiplying to x. So how much you are going to get? 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9 x is equal to, if we are going to multiply this much with x, so how many digits will come forward? Decimal से पहले कितनी digits आ जाएंगी? 9 with 43. So 43, 1, 2, 3, 4, 5, 6, 7, 8, 9 point. Again repetition, decimal के बाद 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. Now subtract this from this, right? So how much you are going to get after subtracting? You are going to get 1, 2, 3, 4, 5, 6, 7, 8, 9 times 9 is equal to, ये पूरा डेसिमल के बाद वाला सेम है इसलिए जीरो होगा डेसिमल के बाद. सिर्फ हमें क्या करना है? 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 में से 43 माइनस करना है. सो हाउ मच यू आर गोइंग टू गेट? 9 minus 3 is 6, 8 minus 4 is 4, rest will be same. 7, 6, 4, 7, 6, 5, 4, 3, 2, 1, 4, 3. So x will be 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6 upon 9 times 9. 8, 9. So this is in the form of P by Q, and we can say that it is what? Non-terminating rational number. It is non-terminating rational number. Non-terminating repeating, I am going to write here, it is non-terminating repeating. Therefore ये किस तरह का हुआ? It is a rational number. So this was the end of this exercise. We have 3 theorems also, which I will give you in written form. So you have to note down from the written papers as well as your last homeworks. Thank you and have a nice day.